Hello everyone, and welcome to our latest Code Presents webinar, the Code Lisperer's Guide to .NET Integration with Microsoft 365. We're excited to have Bob Calco from Apex Data Solutions presenting for us today. My name is Jim Duffy, and I'm responsible for the marketing and sales efforts for all of our code services, including Code Magazine, of course, but Code is so much more than just our magazine. Code's continuing mission is to help people build better software. We're a Microsoft partner and provide a number of services under the Code brand umbrella, including building custom software solutions on-prem and in the cloud, modernizing legacy applications built with tools like Visual Basic, Microsoft Access, Fox Pro, ASP Classic, even early .NET WinForms, and others as well. We also educate developers with webinars and training courses. We provide developer resources to augment your developer team, as well as support and maintain existing applications. Our team of expert developers and consultants are ready to help you with your project. Your ticket to free consulting is our very popular free hour of code service. It's a free hour on us. No strings, no commitment, no credit card required, just free help from our code experts. It provides an opportunity for you and or your team to meet with our experts to discuss anything you could use our help with. Slots are limited, so reach out to me today about getting your free hour of code scheduled for you and your team. We are hiring developers. If you're looking for a new gig, come join the Code Consulting team. We have multiple positions open. Please follow the link on the slide for all the details. If you like what you see today, or have seen in our prior webinars, please subscribe to our YouTube channel, follow us on Twitter, like us on Facebook, and follow us on LinkedIn. Code Magazine is the leading software development magazine written by expert developers for developers. All registered attendees who don't already subscribe will automatically receive a free digital Code Magazine subscription. I've also included a free subscription link here for you to share with others who couldn't make it to the webinar. The Code mobile app is available for both iOS and Android. It's the ideal way to read Code Magazine on the go. We would like your feedback about the webinar in the form of a quick survey. The survey will be available once the webinar has been underway a bit. We want your feedback, and we're willing to pay $100 in the form of an Amazon e-card to one lucky attendee. A name will be drawn from the entire webinar's registered attendee list, and a completed survey is required to qualify for the e-card. The survey link is on the slide, and we'll post the survey link in the chat window as well. Have you heard about Photino? Photino is an open source project the Code team is involved in that allows .NET developers to create native cross-platform desktop applications using web development technology. You can leverage your HTML and CSS and JavaScript skills to create desktop applications that run on Windows, Linux, and even the Mac. It's like Electron, only smaller and much more lightweight. Learn more at tryphotino.io. The slides and recording of today's webinar, and all of our webinars, will be available on the Code Presents webpage on the Code website. All registered attendees will receive an email after the event directing you to the slides and webinar recording as well. Our presenter today is Bob Calco. Bob is the chief architect and lead developer for Apex Data Solutions. He's an experienced enterprise architect with unique experience in the data federation and interoperability space. He brings 20 years of experience to the table, and we're excited to have Bob present for us today. If this is the first time attending one of our webinars, welcome. Thank you so much for joining us. If you've attended one of our webinars in the past, welcome back. Thanks for listening and enjoy the webinar.
Hey, I'm Bob Calco from Apex Data Solutions, and today's presentation is the Code Lisperer's Guide to .NET Integration with Microsoft 365. Reader's Digest condensed version of my bio there is that I'm an enterprise architect with unique experience in data federation and the interoperability space. Though I play the role of proselytizing Lisp evangelist in this talk, in reality I'm a true polyglot who loves exploring how languages support our attempts at abstraction, and a true believer that how you think about a problem usually is the problem, which is why I love this profession. As promised, we'll be talking about Lambdas, database transparency, Lisp macros, and microservices, but each of these topics could easily take hours to cover in detail. The presentation will be a high-level introduction to the topics, which we'll be covering in more depth in future articles and webinars at Code Magazine and other venues. Today's agenda is as follows. I'm sure you've got lots of questions about the motivation for extending Office with what we blithely term the proper Lisp, and what that has to do with linked data and microservices. So before we get into the specifics, we'll answer the questions straight up. What we're really interested in is rethinking legacy application modernization. It's an overloaded term with not too many great connotations, and we'd like to change that. We'll give an overview of our vision for a world of real data interoperability, which is what we're really all about, and discuss what we see as the phases of interop and how our tools will be addressing the needs of enterprises toward this end. Finally, we'll give a quick update on what's coming more near term with our flagship Accelerate and Accelerate Pro products and where they fit into the big picture. Obviously, if someone asks the average IT person what the modern approach to legacy application modernization is, the answer, preparing a system of record or data silo for real-time data sharing and general data interoperability, is probably the last thought that would occur to them. More likely, they would give some very different, probably more jaded answers. And that's because the term is overloaded to a point that all it conveys is that something old is moving to something new. And this is not a helpful construct, but it's a common one. So let's deconstruct it. In reality, there are a few broad buckets into which legacy application modernization attempts are either pitched or dumped, as the case may be. There's stack-driven legacy application modernization, where version deprecation or loss of long-term support force an upgrade to some new version of one or more components of the development stack, or the newest version of the stack has some whiz-bangs we might want someday. There's legacy app modernization driven by management needs, where beloved systems are ripped and replaced in favor of something else that gives management nicer dashboards. We've all been there. There's also buzzword-driven legacy app modernization, in which investors put their thumbs on the scale of a re-architecture, mainly to be able to say the solution is now officially trendy. What these all have in common is that typically, if you really look at them, the risk is much higher than the reward. So the question occurs to us, is there a good reason to modernize an application that's always justifiable? And is it something we can describe in terms that people can actually implement? So it's a question that our work in enterprises and large government organizations have us pondering frequently. I think there is a good reason that is always justified and a way to do it with minimal risk, but first we need to consider what we mean by modern. One distinguishing feature of modernity, with which we're all familiar, is the instant asynchronous nature of communications. This makes us wonder, how is it that we can share our thoughts with strangers half a world away in mere seconds, but our computer systems can't? They can't share information or batch information reliably, even on a monthly basis. So IT systems have been moving toward a loosely coupled point-to-point messaging paradigm for some time now. Data silos not sporting RESTful APIs or participating in pub/sub messaging are getting left behind slowly. But this model, while intuitive from an anthropomorphic point of view, is flawed. Is point-to-point really the right abstraction here, at least for IT systems, which after all are not people? So let's take a step back and ask ourselves what a fully modern system might look like. It should be something that's inherently reactive. That is, it generates and incorporates change easily. It should be self-descriptive. That is, it should provide metadata, ideally in the language of the domain. It should be extensible. Coding, testing, and deploying should be as frictionless as possible. And it should be available, easy to scale on anyone's cloud. Toward this end, when talking about legacy systems in general, not just Office 365 in particular, which we'll get back to, we find that the adapter pattern is always our friend. Most of these requirements are too hard to jam into systems not originally designed with these goals in mind. When we talk about microservices, we're generally talking about SOR adapters then. Our goal is to make change as painless to the legacy application as much as possible. So we have some goals in the specifically 365 context. First is to be able to leverage the reach and power of .NET. It runs everywhere now, not just on Windows, where it's the de facto development platform of choice. We like the language that we use to implement our goals, that it should be simple, extensible, and easy to teach, even to non-programmers. This is always a controversial choice, but we feel comfortable defending Lisp here. We need to run in and outside of Office, on Windows and in the cloud, which further reinforces our need to leverage .NET, because that's the only thing that can touch all those places. We need to speak the language of the domain in linked data terms. We'll touch on this a bit later, what it means. It's a big topic. And it should interoperate with existing VBA solutions. This is a big deal. Indeed, we see our approach as VBA friendly, and we hope VBA and Office developers generally give our approach a try. So this is the obligatory why not VBA slide. Well, it can't take advantage of .NET, not directly and certainly not completely. It's based on COM, which doesn't really run anywhere but Windows. VBA itself is being deprecated long-term by Microsoft in favor of Node.js-based add-ins. These haven't really proven themselves yet in terms of performance, so VBA devs have some time to get either on that bandwagon or find another one, so to speak. Microsoft is, in any case, determined to move Office itself to their cloud eventually. Even VB.NET, which is the flavor of BASIC in CLR, is being deprecated by Microsoft. They're not really adding features to it, and they're kind of like letting it be stable now until they can move on to something else, perhaps. Anyway, I never really found BASIC, despite its name, to be any simpler or any harder than any other imperative programming language to learn. And in my opinion, its syntax isn't really simple. I think people are just used to hearing that it's so simple, but not simple in the sense that we mean, in the sense that a proper list satisfies, which we should probably talk about. So let's talk about it. Yeah, we want to use Lisp, not just one, but two. We've got Scheme for casual everyday scripting, Excel Lambdas, and intra-office automation. We've got Clojure in our Professional Edition for portable microservices, advanced data-oriented development, and deeper platform integration. Both run on .NET, which means, as a bonus, that interop with existing VBA solutions is actually straightforward via Office primary interop assemblies, which we've wrapped. If you're still wondering what's so special about Lisp, you should know that you're in great company. For decades, it has fascinated developers and language designers because of its simplicity, and it's a very deceptive simplicity because you can build literally anything on top of it. It took a long time for me to find my road to Lisp, but over the last 6 or 7 years, I can honestly say that it's changed my view of computing and made me appreciate the elegance of code in a mathematical sense in ways I never could have imagined. It's really something everybody should learn, even if you don't use it. Eventually, even the parentheses look beautiful if you really grok it. In particular, I like Alan Kay's quote here. Alan Kay was the inventor of Smalltalk, another amazing language which everybody should know something about and look into. He said, Lisp isn't a language, it's a building material. And I think that's a very accurate statement. When you really understand what you're working with at the elemental level, you have an amazing freedom to build what you want. And that's what most folks who get into Lisp really like about it. Yeah. Okay, you say, I get that you want to work with Lisp. That's all well and good, but why two of them? What's the big win here? The answer is that a solution in the data interoperability space is not a simple thing under the hood. There are specializations in the diverse family of Lisp languages that are worth understanding and, when available, leveraging. And it happens that on .NET, both Scheme and Clojure are fully functional and fully available. So then you have to ask yourself, well, what are they good for? Different things, it turns out. Scheme has an intentionally tiny syntax and a philosophy of minimalism that makes it ideal for beginners. It sports a powerful syntax extension facility, like every proper Lisp should, that makes it possible for the programmer to turn it into the language they need for the domain, rather than treating the domain like Procrustes and chopping off the requirements that the language can't satisfy. It's ideal in certain niche places in Office 365, particularly as a companion to Excel's new built-in concept of Lambdas and the functions related to those. Clojure, which is offered in our Pro Edition, was specially designed to be a hosted language with unique features for concurrent, functional, and data-oriented programming. As a hosted language, meaning it was designed to run in a runtime like Java or CLR, its interop with the host is more complete than that of any other Lisp that's been ported to such runtimes, even Scheme. In fact, it runs on the JVM, the CLR, the JavaScript runtime, even Erlang's virtual machine, which means it's truly an intriguing option for building interoperable frameworks. These are frameworks that, at a top-level coding API level, run the same across different runtimes. It hasn't gotten a lot of play yet on .NET, but we hope to change that because it's really worth looking into for enterprise solutions. Regarding the simple syntax, this slide attempts to show just how simple, minimal, and beautiful the syntax is in both flavors of Lisp that we support. So depicted in both columns are simply the identity function. You've probably heard statement in logic class in school, A is A, which is like the fundamental law of identity. So basically, this function takes A and simply returns it. So if A is a string, you get a string back. If it's a number, you get a number back, whatever kind you pass in. The point here isn't what this is doing because it's not very useful. The point is how easy it is to define a function, and this is probably the simplest function that you can define. The reason why it's so easy is because under the hood, if you look beyond the syntax sugar in the top line of both columns, there are lambdas, what they say, quote unquote, lambdas all the way down, which means the entire system is built on top of very basic primitives. Lambdas are based themselves on the lambda calculus, as mentioned before by Alonzo Church. He was the first person to start formalizing lambda calculus, and then along came James McCarthy, who decided to build Lisp as an expression of a language that could run lambda calculus on a Turing-complete machine. That's actually how Lisp got started. Although scheme syntax here looks a little bit more verbose slightly, in reality, Clojure's got a lot more going on under the hood. Of the two of them, Scheme is the less complicated language with more straightforward and consistent rules. And for this reason, we think it's more ideal in the role of closer to the VBA programmer or even the Office user per se. Clojure was really designed for concurrency and scalability and enterprise applications. So the Professional Edition, as I mentioned earlier, makes using Clojure an option, particularly for tasks more likely to be performed by enterprise developers anyway, where Clojure on the JVM is already popular. Bottom line is all Lisps give you certain things that you can kind of count on. First-class functions. This is especially powerful in either an Excel or even a SQL context. In fact, lambdas you write for Excel can be used alternatively as SQL custom functions in SQLite, and that's something that we are quite proud of. There's composition in every permutation of function passing and returning you can imagine. These are things that are not really possible in VBA and many other languages that you might choose from. Both Scheme and Clojure are mature for large-scale development with libraries in the Scheme sense and namespaces, all of which support modular, team-based distributed programming. And in contrast to VBA, where the code is stored in the document, and we've made a conscious decision not to do that, so that all the code could be set up on your system with a search path to reach into many libraries that you can pull down off Git, for example. We also want full embrace of the runtime, in this case, the CLR. And that's kind of a concept you got to wrap your head around. For two different completely fully implemented Lisps with all the libraries you could pull in from those languages, you also have the full power of the .NET runtime at your fingertips right inside Office and outside of it for that matter. So that's a really powerful concept that may take a while to sink in, but as you really start to explore it, I think you'll find it kind of amazing. So we have macros. Every Lisp has macros, and that makes it inherently moldable to the domain. It favors a style of coding that's kind of bottom up versus top down, but really because of the modular programming support and namespaces and all that, you can build both ways: top up, top down, bottom up, and in the middle. The macros enable you to implement features like link, the database transparency, which we'll talk about in a bit, and other alien powers. It's really Lisp's secret weapon from outer space, and we'll show some quick examples in a bit. Just to reiterate, you have the full reach of Scheme, meaning every Scheme library out there, with very few exceptions, will run in our .NET flavor of Scheme, which is based on Iron Scheme. This means that libraries like Minicanron, which supports logic programming and very advanced unit testing, it's already built in. It's part of the product. We also support dozens of what they call SRFIs, or Scheme Requests for Implementations. This is the Scheme community's way to suggest, arbitrate, curate, and eventually approve or disapprove of potential changes to the language at the syntax level, which, keeping in mind that this can all be done with macros, means that anybody can support a construct if everybody agrees on it in their favorite, dialect of that particular language, in this case, Scheme. So you'll find that there's dozens of ones supported under the hood already as part of this. Similarly, we have the full reach of Clojure, and it's quite straightforward to port. Well, it's mostly straightforward to port JVM-based libraries to the CLR using what are called reader conditionals, which give us a way to sort of isolate code that's specific to the runtime that you're actually in when it's running, or in this case, compiling. So in reality, this is 3 wins in one. You get all the reach and power of Scheme, all the reach and power of Clojure, and all of that on top of the full reach and power of .NET. And we think that's a big deal. So let's talk a bit about this idea of database transparency that will make a debut in the next edition of Accelerate and Accelerate Pro. Everyone stores data in Excel spreadsheets, even though everyone knows they shouldn't. This is usually because database connectivity is often highly restricted in enterprises, too hard to fathom for normal users, people who don't understand SQL or what an ODBC connection is, etc. And so they store the data in Excel. Many solutions, they use ODBC or VBA talking through ADO or OLE to access, if access is used at all. In any case, both Access and Excel have hard size limits that are impractical for larger systems. So we asked the question, what if interacting with data in Office, and particularly in Excel, and Access for that matter, was not bound to the documents per se, but integrated into the language of Lambdas for automation and integration purposes? Here we have in mind thinking of the old FoxPro paradigm, and that was the first database I cut my teeth on a long, long time ago, where the SQL language was baked right into the programming language. Well, Lisp can do that too, and that's one of the main reasons I kind of fell in love with it. So let's take a quick Scheme example of what macros can do. Out of the box, there is no for each statement, there is no from, where, any of that, all of which will seem somewhat familiar to .NET developers, but it'll also feel familiar to the old FoxPro neckbeards. In this case, you're using the language itself to express connecting to a data source and pulling data out, and then further refining it with a predicate. So imagine you got a variable all clients query that encapsulates a select all from client, select star from client. The code above iterates through the results and printing the details for those Smith clients whose last name is Smith. Now, this query could have been done entirely in SQL, we get that, but the result of the from clause could also be bound to a variable, which could then be used in a variety of for each statements without having to hit the database again. None of that's really the point. The point here is that for each and from clause are the result of macros. About 900 lines of Scheme code were all it took to implement the link specification for C# in Scheme. Really, 900 lines. The macros for turning .NET IEnumerators into IEnumerables were also added. Now all of a sudden you can frisk any .NET Scheme or SQL result that you may want right within the syntax of the language. By the way, even Office collections in the Office API can be manipulated this way. That's how powerful it is. And this is why we love Lisp. Code is just data. This is a property called homoiconicity that means code is just data and vice versa. It means that you can write code that writes code. You can write code that lets you write code exactly how you want to write it, limited really only by your imagination and the needs of the domain. In reverse order, of course. You don't have to wait for me or someone at Microsoft to implement something you want. You can make it happen by learning how to write macros and syntax extensions. That's really the cool part. So to consider another quick example here, I kind of crammed it onto the slide. Sorry if it's not really super easy to see. But basically, this is a Scheme script. It loads the unit testing and SQLite libraries that we've wrapped all this stuff in. The first red line, we're defining a function called ultimate answer that returns the value, naturally, 42. The second set of red lines is a definition of a custom SQLite function of the same name that itself returns a call to ultimate answer. We didn't have to wrap it in another lambda, but it makes the nature of that, what the function is in this context, a little bit more explicit. The third set of red lines is a unit test using a macro we created to make it possible to write plain English tests that, when errors are encountered, provide meaningful messages. All of these are just little examples of hugely powerful feature unique to Lisps. And once you get the gist of them, they're an amazing tool for eliminating boilerplate code and molding the language to the domain or to your domain organically. I particularly like the simplicity of the SQLite function. There's a whole story there which I could get into in the Q&A if anybody's interested about implementing something like that and what it took. And also the unit test down there. It's just so easy to read. Check that ultimate answer result from SQLite custom function test is equal to 42 because the answer to the ultimate question of the universe is 42. It's self-explanatory, reads nice, it's easy, I love it. Anyway, that's just an example. That same lambda defined in the previous example returns the same result when called from the lambda function that our Accelerate add-in provides in Excel. So you can see that we have a lambda function that's actually a lambda, and it's calling ultimate answer and returning 42. You could do the same thing by simply calling the already defined ultimate answer function because it's loaded through an initialization file when Excel starts up, if you put it there. And you can just call it using eval as well. This means that for any very complicated or more involved solution that you'd have to code, you still have a very simple entry point in Excel with very minimal code to have to write in the actual spreadsheet itself. And there's a whole process that we teach people to kind of go from playing around in the REPL, which isn't shown here, to promoting it to a Lambda, to moving it into code on your machine that you can still access from within Excel. All of this opens the floodgates of what's possible in Excel, and indeed all the other Office apps as well. Right, so jumping back to Clojure real quick as we wind up, note that when we're in the Clojure CLR REPL, which we get into by calling ADB VCA REPL, and we create this what they call reader conditional. It's the pound question mark and then what happens within the parentheses of that. In Clojure, keywords typically have a colon behind them by convention, and so you can see that there's a mapping of keyword to something being implemented. Here we're just returning strings, but there could be an entire block of code that calls a specific library in that runtime. So in this case, if I'm in the Clojure CLR runtime and I type this expression, what comes back is .NET rules because we're working in .NET runtime, which has the extension CLJR. When we hop over into the next line there under CLJ, we go into the Java runtime and we run the same expression. We're going to get Java, Java, Java because the CLJ is what will compile under the Java environment. This means that Clojure is particularly well suited to write APIs that work regardless of the underlying runtime, which is an important goal. If you look at high-level architecture of Accelerate DB, and this is a vast oversimplification of what's under there, I'm just showing three components here: the RDF or linked data support. Under the CLR, the natural choice is .NET RDF. For Office artifact querying and interacting, we have DevExpress Office API components, which we've included in the product, and we have Microsoft SQLite wrapper. On the JVM side, you can get the same effect by using Apache Jenna for RDF, Apache POI for Office interop, and the gazillion SQLite wrappers for Java. The point being here that the code at the top level Clojure in Accelerate DB will be the same, regardless of which runtime you're on top of. And that's a very important point. That means that the same knowledge of the API conveys across runtimes. And that's one of the things that's kind of been missing, in my opinion, to help with the interop problem, albeit this is interop at more of a dev stack level. It's still a kind of interop, and it's very important to understand how these constructs map. And so in this picture, mainly what I'm trying to convey here is that choosing Clojure gives us the freedom to build full solutions for both the CLR and the JVM with a common top-level developer API. Again, the big goal here is general data interoperability. Microsoft 365 solutions in the enterprise are typically ad hoc silo applications, which someone created because they were miffed at IT not solving a problem for them, so they went and they solved it themselves. And these generally pose huge challenges to the enterprise data architects, who typically find out about them too late after they've already built some stuff, and they're like, oh, if only someone told me about that. So there's that story we've seen so many times in so many organizations. And even though that's kind of an anecdotal framing of it, believe me, it is a big problem. Most IT landscapes in big corporations are littered with Excel spreadsheets and Access databases that were kind of homegrown in some department. They contain very important domain information, business logic, whatnot, and they're typically overlooked in the process of building bigger systems. Similarly, in small business, office solutions are typically very domain specific, typically one-off, built by a single person or two. They generally have a narrow path to upscaling when the organization outgrows them. It's usually move up to SQL Server or SharePoint or something like that. What we need is a way to transform these data artifacts and data silos into shareable information and deploy them as linked data microservices according to best enterprise practices. That's at some level what we mean when we talk about a system of record adapter. Where are we getting this concept of interoperability? I thought it was worth spending a moment on this. In healthcare, people have given this problem a lot of thought. Another area that really needs to think about it is finance, but healthcare, there's a very acute need to share clinical information across organizational boundaries, which is incredibly hard because of the nature of IT in big organizations. So HIMSS is an organization very well known in the healthcare space. They have 2 conferences a year that people go to in either Orlando, Chicago, or I think Las Vegas. It's where all the big companies in IT related to healthcare go to pitch their wares and hear about new things and whatnot. So they've spent a lot of time thinking this problem through, and they have kind of described 4 levels of interoperability. And the first level is, just systems connecting to each other, TCP/IP. Send data, receive data. You're level 1. Everybody's level 1. Level 2 gets a little bit more detail about the format, the syntax, the organization of the data exchange, and at the data field level. And this is where XML flying all over the place. So most places that have message hubs and whatnot are level 2 now. Level 3 is a work in progress. It really gets the idea of, this is where linked data comes in. It's an information model that allows you to allows machines to reason about the information that they're encountering. It allows them to recognize and act on concepts. This is a slightly higher level, as you can imagine, from level 2. And in healthcare, there have been a lot of projects to do mappings from internal domains like what is a clinical observation? That's what SNOMED tells you, and then you got LOINC and all these other like RDF-based sort of ontologies. But all the time has been spent on the inter part more so than the operability part, and that's where I think we're trying to really contribute some advances here. And that's why we embrace the HIMSS definition, because it doesn't preclude what we're doing. It's just what we're doing is a different approach, but it's the same goal. And our goal really is to hit level 4. This includes governance, policy, social, legal, and organizational considerations to facilitate secure, seamless, and timely communication and use of data both within and between organizations. So this is what we're striving for. And it's a big goal, to say the least. So I thought we'd share that with you, because that's really where we start thinking about where are some of these big pain points, and that's why we're doing some of the things we're doing here. So the keys to a solution. We need something based on linked data, which allows for mapping concepts across domains. We'll talk a little bit about that in a minute, and thereby to make sense of data and a diversity of representations that we encounter. Office solutions and artifacts need to be first-class players in the new microservices architectural style. At the end of the day, the documents are just data. They don't do anything until you run an application that uses them, like Excel or PowerPoint or Word or Access. But they're files with information in them. And there are APIs that can get at that data, even if they're running on different platforms, because of Microsoft's decision to standardize on the docx and the OpenOffice XML formats. So there's no reason not to consider this. It's one way to take the app and make it useful to the enterprise, that I think is kind of obvious and straightforward when you have that as your goal. We need a open, extensible programming model. This is something that Lisp excels at. We need a flexible, internet-savvy deployment model. These are all things we want. And so when you think about, ask yourself, so before we can have that, what do we need? What are the prerequisites? And I think this is where the interop has like a chicken and egg conundrum. If you had the way to operate, you're really not ready for it, even though you've kind of done some mapping of things, because you haven't contemplated a sane model for how this happens in a correct way, right? So we get to the chicken and egg problem. We need to take the systems and adapt them to the language of the domain. We need an intermediate language of the domain. This is what RDF satisfies, so that we can participate in the change propagation model that we want and that we alluded to earlier. We really want to avoid throwing bad data after good data. So there has to be a curation model that needs to be considered as part of this process of data propagation. And again, linked data is a powerful tool, so we need to get our head around that, at least at some top. What is linked data? Well, it's a standard by W3C. It's an information model, goes by the name RDF, or Resource Description Framework, and it's based on statements of fact. Okay, so it's not just like, data model with classes and attributes or entities and properties or anything like that. It's really, you're making a statement of fact, and these statements of fact are called triples because there are three pieces to them, at least at the simplest level. There's more complicated ways to think about them, but at the core, you're talking about a subject, the thing we're talking about, a predicate, which is a property or an attribute that we associate with the subject, and an object, which is the valid value for the property for that subject. Okay, so these triples, more than one triple forms a graph. And once you start thinking about a graph, you have to kind of grasp the idea of the open world assumption that's part of this. And this is something that's different from a database. A database has what's called a closed world assumption. So in the closed world assumption, if the data ain't here, it ain't. In the open world assumption, we say just because the data isn't in this graph doesn't mean some other graph doesn't have it. And so therefore we have a slightly different way that we think about querying for things and particularly reasoning about them. Graphs can be queried in a language called Sparkle, which is similar, but very different in some ways from SQL. I call it the original GraphQL because I think it does GraphQL better than GraphQL because you have semantics. In fact, you can, in a Sparkle query using RDFS plus and OWL, which OWL stands for Ontological Web Language, you can actually do reasoning in a query. So you can have queries that generate new information from existing information based on reasoning rules, which you can specify and load in their own files and whatnot. So it's a very powerful model for thinking about information. It's an information model more than a data model. And it's designed to allow you to express any concept that you want to think about, and then express a mapping of those concepts to existing real world things. Whether they're things in the real world or things in a database that represent them. And so it's really the most mature thing going for thinking about data interoperability. But it has suffered a bit from complexity. So our goal is to make it really simple, even for people in an office context to use, without having to necessarily get very deep with the concepts. This is why we would bring developers in to do some of the lower level stuff. But at a base level, we really want to bring linked data into Office. So we want to bring a disciplined approach to this reactive data propagation. And so we have these three phases as we see it, like level one or phase one. We're preparing the systems of record for a world of interoperability. That's really what Accelerate Pro is about. The goal is to adapt the legacy systems of record for change propagation. That means, in most cases, mapping them to some intermediate language of the domain, which we have to describe and agree to. And that can happen at the enterprise level, can happen at an organization level within a big enterprise. The point is, it's scoped to some effort. The phase two is where we really begin to initiate change propagation. Now that we have the systems ready to report and incorporate change, now we can start to kind of wind them up, so to speak, and let them do their thing. And this means that we're going to be enabling real-time data propagation, data change propagation. And that's where our next product, which we're working on, Domain Master, comes in a little bit later this year. We'll be talking about that. We like to think of Domain Master as kind of unifying a box because it's really got all the pieces and it's really aimed at the desktop. But Unify is the scalable version of the same thing. In this case, we want to enable data exchange with maximum organizational autonomy over how we use the data, but with strong guarantees about state and time. That's the hardest thing about interop is that you need to have a strong concept of state and identity over time, because you need to know how information got to the state it's in. You need to know who contributed to that. You need to know, particularly in clinical settings, we have found that the more information a clinician has, even if their system of record can't fully express it, the better they can do their jobs. And I think that there's a real value in having that aggregated information in a guaranteed state. And you can talk more about this in the Q&A if it's of interest, but it's really important to be able to guarantee at any point in time that we all have the same information, even if it's not complete, even if it's somewhat wrong. Like, it's important to have that be the same. Otherwise, we really can't think about how to update our systems of record in ways that won't do more harm than good. All right, so getting back to near term here, what to expect in the upcoming release of Accelerate Pro boils down to kind of three big points. Better tooling inside of Office for solution developers. So we already have a REPL scheme. We have Lambda editor. We've got access to lower level REPLs. We have some basic logging and ability to see stuff. That's all very, first version like we have out there now. We will have better tools in there for both versions of the product, but in particular for Pro. We're going to add Clojure as a first-class automation and cloud kind of deployment language. Deeper support for linked data and microservices to aid in interoperability. This will be in both Scheme and Clojure. Operationally speaking, we have this thing we are calling Accelerate DB, which begins to implement this notion of a strong time and identity-based model, which we could dive into at some point. That's I think really going to be the killer app for this, but we'll see. Anyway, those are what you can expect coming up in the near term. So let me just summarize here. Extending Microsoft Office and 365 with the full power of .NET adds real value to the goal of enterprise operability, of course, but also to anything you might want to do in Office. It really expands the realm of the possible. Leveraging a proper Lisp as the .NET integration language multiplies that value because of the unique properties of Lisp as an especially domain-modable language, and not to mention the vast number of libraries that have been written over the decades that still work and run that are available on top of .NET. There happens to be two proper Lisps on .NET, and we use them both for different use cases in Accelerate Pro. We talked a bit about why between Scheme and Clojure, what their strengths are. All of this was done in the service of our interoperability mission, but you can use the same tools for any domain and for any purpose. Indeed, Office 365 can be finally a platform for developing interoperable solutions, both for small businesses and for the enterprise. And that's kind of like in my mind, the big deal about it, above and beyond what we Apex are doing with it. And so that's it for now. Obviously, that was high level, but we'd love to dig deeper into these topics if you're interested to hear more. Now I'll take any questions that you might have. If we don't get a chance in the Q&A session to talk, then please feel free to email your questions to me at bob.calco@apexdatasolutions.com. And of course, you can visit our website at apexdatasolutions.com for more information as well. So now we'll get on to the Q&A.
Interesting stuff, Bob. I'll remind you that we're very interested in your feedback about this webinar and would appreciate you taking a moment or two to complete our survey. It's all of like 12 questions, so you fly right through it, and one lucky attendee will receive a $100 Amazon e-card. As a benefit for registering for this webinar, all registered attendees who don't already subscribe will automatically receive a free digital Code Magazine subscription. Please share this free subscription link with others who couldn't make it to the webinar. Code Consulting is hiring. Come join the Code Consulting team. We've got multiple positions currently open, remote and on-site. Full-time and contractor positions are available. Follow the link for more details. Through our free hour of code offer, you can ask for our help on whatever you or your team needs. No strings, no commitment, no credit card required, just help from our code experts. Reach out to me about scheduling your free hour of code. The Code mobile app is available for both iOS and Android. It's the ideal way to read Code Magazine on the go. Register today for our October and November Code Presents webinars. Secure microservices on October 12th and improving string handling performance in C# on November 9th. We look forward to having you attend. Our fearless leader, Marcus Egger, will be back in October and November for our next State of .NET webinars. He'll be addressing .NET 7 in October and the state of AI and machine learning in November. The dates are to be determined and will be published on the Code website soon. Speaking of .NET 7, mark your calendars for .NET Conf 2022 on November 8th through 10th. It's a free 3-day virtual event where you'll learn about what you can do with .NET 7. That's it for today's presentation. Don't forget to subscribe to our YouTube channel, like us on Facebook, follow us on Twitter. If you're attending live, we'll be in the chat for a while answering any questions that you may have. If you're watching this post-event recording, please don't hesitate to reach out to me or through any of our communication channels. Thanks for attending, everyone. Have a great rest of the day or night wherever you are.